Determining wire size and current capacity is crucial for service upgrades. Based on the rubber insulation and a 0.75-inch outside diameter, the cables are likely THWN, which stands for thermoplastic heat and water-resistant nylon. THWN cables typically have a temperature rating of either 75 degrees Celsius or 90 degrees Celsius and a voltage rating of 600 volts. To accurately determine the wire size, consult a wire gauge chart taking into account both the outside diameter and the insulation type. It's highly probable that the existing cable is a number 2 American wire gauge THWN cable. The current capacity of a number 2 American wire gauge THWN cable is 95 amps at 75 degrees Celsius or 110 amps at 90 degrees Celsius. When upgrading to a 100 amp service, if the existing cable is indeed number 2 American wire gauge THWN, it is generally considered sufficient for a 100 amp service at 75 degrees Celsius. However, if the temperature rating is 90 degrees Celsius, it may still be necessary to replace the cable with a higher rated one depending on local codes and specific installation requirements. For a 150 amp service, a number 2 American wire gauge THWN cable is inadequate, irrespective of the temperature rating. In this case, installing new number 1 American wire gauge or larger cables from the street is essential. There are additional considerations to keep in mind. Firstly, verify the precise temperature rating of the existing cable. This information is usually printed on the cable's jacket. Secondly, carefully check the size of the conduit or raceway where the cables are installed. It may need to be larger to accommodate the increased amperage of a 100 amp or 150 amp service. Thirdly, thoroughly consider the age and overall condition of the service entrance panel. It may need to be upgraded if it is not explicitly rated for the higher amperage. Due to the complexities involved, consulting with a qualified electrician is highly recommended. A skilled electrician can accurately assess the existing wiring, precisely determine the wire size and current capacity, and provide tailored recommendations for any necessary upgrades or replacements. These upgrades will ensure that the electrical system can safely and effectively handle a 100 amp or 150 amp service. When considering upgrading electrical service, several factors influence the choice of wire size and the overall feasibility of the project. Firstly, the ampacity of the wire, or its current carrying capacity, is a fundamental consideration. This is directly related to the wire gauge and its insulation type, as well as the ambient temperature and installation conditions. Secondly, voltage drop must be accounted for. Over long distances, voltage drop can become significant, leading to inefficient operation of electrical equipment and potential overheating. Larger wire sizes reduce voltage drop, ensuring that appliances and devices receive the correct voltage. Thirdly, the National Electrical Code, or NEC, provides guidelines and regulations for safe electrical installations. These codes specify minimum wire sizes for various amperage ratings and installation scenarios. Compliance with the NEC is essential for safety and to meet legal requirements. Fourthly, the type of load being served also influences wire size selection. Continuous loads, such as lighting and heating, require larger wires than intermittent loads, such as motors and appliances that cycle on and off. The NEC defines a continuous load as one that operates for 3 hours or more at a time. Fifthly, environmental factors, such as temperature and humidity, can affect the ampacity of wires. High temperatures can reduce the current carrying capacity of wires, requiring the use of larger sizes or dirting factors. Similarly, wet or corrosive environments may require special insulation types to prevent degradation of the wire. Sixthly, the method of installation, such as conduit, cable tray, or direct burial, also affects the ampacity of wires. Wires installed in conduit may have a lower ampacity than those installed in free air due to reduced heat dissipation. Seventhly, future expansion should be considered. If there is a possibility of adding more electrical load in the future, it is wise to install larger wires than currently required to avoid the need for costly upgrades later on. Eighthly, the available space in the conduit or raceway may limit the size of wires that can be installed. Overfilling conduits can lead to overheating and damage to the wires. Ninthly, cost is always a factor. Larger wires are more expensive than smaller wires, so it is important to balance the need for adequate capacity with budgetary constraints. Tenthly, proper grounding is essential for safety. Ground wires must be sized appropriately to handle fault currents and protect against electrical shock. In this specific scenario of upgrading from 60 amp fuses to 100 amp or 150 amp service, a careful assessment of the existing wiring is crucial. If the existing wires are indeed number 2 American wire gauge THWN, they may be adequate for a 100 amp service, but only if the temperature rating is 75 degrees Celsius and all other conditions are favorable. For a 150 amp service, new number 1 American wire gauge or larger wires will definitely be required. The electrician will also need to evaluate the service entrance panel to ensure that it is rated for the higher amperage. If the panel is old or in poor condition, it may need to be replaced. Additionally, the grounding system will need to be inspected and upgraded if necessary to meet current code requirements. The process of upgrading electrical service typically involves several steps. Firstly, the electrician will perform a load calculation to determine the total electrical demand of the building. This calculation takes into account all of the appliances, lighting, and other electrical loads that will be connected to the service. Secondly, the electrician will select the appropriate size service entrance panel and overcurrent protection devices, such as circuit breakers or fuses. Thirdly, the electrician will install the new service entrance cable from the street to the service panel. This cable must be sized appropriately to handle the calculated load. Fourthly, the electrician will connect the new service panel to the existing wiring in the building. This may involve replacing some of the existing branch circuits to accommodate the increased amperage. Fifthly, the electrician will test the entire system to ensure that it is working properly and that it meets all code requirements. It is important to note that electrical work can be dangerous, and it should only be performed by a qualified electrician. Working with electricity can result in serious injury or death if proper precautions are not taken. Always de-energize circuits before working on them, and use appropriate safety equipment such as insulated tools and rubber gloves. Furthermore, it is essential to obtain all necessary permits before starting any electrical work. Permits ensure that the work is inspected by a qualified electrical inspector and that it meets all code requirements. In addition to the technical aspects of upgrading electrical service, there are also some practical considerations to keep in mind. Firstly, plan the project carefully and obtain multiple quotes from different electricians. This will help you to get the best price and to ensure that you are working with a qualified and reputable contractor. Secondly, be prepared for some disruption during the upgrade process. The power will need to be shut off for several hours while the work is being done, and there may be some noise and dust. Thirdly, communicate clearly with the electrician about your expectations and any specific requirements you may have. This will help to ensure that the project is completed to your satisfaction. Fourthly, keep a record of all the work that is done, including the permits, inspections, and invoices. This will be helpful if you ever need to make any repairs or modifications to the electrical system in the future. Fifthly, consider the long-term benefits of upgrading electrical service. A larger service can provide more capacity for future expansion, and it can also improve the safety and reliability of the electrical system. In some cases, upgrading to a larger service may also increase the value of the property. Therefore, it is essential to carefully weigh the costs and benefits of upgrading electrical service before making a decision. The decision to upgrade to a 100 amp or 150 amp service requires careful consideration of various factors. These include the existing electrical load, future electrical needs, the condition of the existing wiring and service panel, and budgetary constraints. Consulting with a qualified electrician is crucial to ensure that the upgrade is done safely and in compliance with all applicable codes. An electrician can assess the existing electrical system, perform a load calculation, and recommend the appropriate size service entrance panel and wiring. They can also identify any potential safety hazards and ensure that the upgraded system is properly grounded. Moreover, upgrading electrical service is not a do-it-yourself project. It requires specialized knowledge and skills, as well as adherence to strict safety protocols. Attempting to perform electrical work without the proper training and experience can be dangerous and may result in serious injury or death. It can also lead to code violations and potential legal liabilities. In conclusion, upgrading electrical service is a complex undertaking that requires careful planning and execution. It is essential to consult with a qualified electrician to ensure that the upgrade is done safely, effectively, and in compliance with all applicable codes. The benefits of upgrading electrical service can include increased capacity for future expansion, improved safety and reliability, and potentially increased property value. However, it is important to weigh the costs and benefits carefully before making a decision. Remember to prioritize safety and to always work with qualified professionals when dealing with electricity. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or upgrades. Electricity can be dangerous, and it is important to take all necessary precautions to ensure safety. When evaluating the existing wiring, the electrician will look for signs of damage such as cracked or brittle insulation, corroded connections, and evidence of overheating. They will also check the wiring for proper grounding and bonding. If any problems are found, the wiring will need to be repaired or replaced before the upgrade can proceed. The electrician will also assess the condition of the service entrance panel. If the panel is old or in poor condition, it may need to be replaced. A new service entrance panel will provide more capacity for circuit breakers and will also improve the safety and reliability of the electrical system. When selecting a new service entrance panel, it is important to choose one that is rated for the appropriate amperage and voltage. The panel should also be listed by a recognized testing laboratory, such as Underwriters Laboratories or all. In addition to the service entrance panel and wiring, the electrician will also need to upgrade the grounding system. A proper grounding system is essential for safety, as it provides a path for fault currents to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The grounding system should be installed in accordance with the National Electrical Code, or NEC. Upgrading electrical service can be a significant investment, but it is important to prioritize safety and to ensure that the electrical system is adequate for the current and future needs of the building. A properly upgraded electrical system will provide reliable power, reduce the risk of electrical fires, and protect against electrical shock. Therefore, it is essential to work with a qualified electrician to ensure that the upgrade is done correctly and safely. In summary, when upgrading electrical service from 60 amps to 100 amps or 150 amps, consider the following points. Firstly, consult with a qualified electrician to assess the existing wiring and service panel. Secondly, determine the appropriate size service entrance panel and wiring based on a load calculation. Thirdly, upgrade the grounding system to meet current code requirements. Fourthly, obtain all necessary permits before starting any electrical work. Fifthly, prioritize safety and work with qualified professionals. Sixthly, keep a record of all the work that is done, including permits, inspections, and invoices. Seventhly, consider the long-term benefits of upgrading electrical service. Eighthly, balance the need for adequate capacity with budgetary constraints. Ninthly, plan the project carefully and obtain multiple quotes from different electricians. Tenthly, be prepared for some disruption during the upgrade process. These points should provide a good starting point for understanding the considerations involved in upgrading electrical service. Remember that electrical work can be dangerous, and it should only be performed by qualified professionals. Always prioritize safety and consult with a qualified electrician for any electrical work or upgrades. Furthermore, it is crucial to understand the importance of adhering to local electrical codes and regulations. These codes are designed to ensure the safety of electrical installations and to prevent electrical hazards. Violating these codes can result in fines, penalties, and potential legal liabilities. Therefore, it is essential to work with a qualified electrician who is familiar with local electrical codes and regulations. The electrician can ensure that the upgraded electrical system meets all applicable requirements and that it is installed safely and correctly. In addition to the technical aspects of upgrading electrical service, it is also important to consider the aesthetic impact of the upgrade. The service entrance panel and wiring should be installed in a neat and professional manner, and they should be concealed as much as possible. This will help to maintain the appearance of the building and to prevent damage to the electrical system. When selecting a location for the service entrance panel, it is important to choose a place that is easily accessible for maintenance and repairs. The panel should also be protected from moisture and other environmental hazards. In conclusion, upgrading electrical service is a complex process that requires careful planning and execution. It is essential to consult with a qualified electrician to ensure that the upgrade is done safely, effectively, and in compliance with all applicable codes. The benefits of upgrading electrical service can include increased capacity for future expansion, improved safety and reliability, and potentially increased property value. However, it is important to weigh the costs and benefits carefully before making a decision. Remember to prioritize safety and to always work with qualified professionals when dealing with electricity.